Hi. Okay, so today's kind of a pleasant surprise here. This worksheet 5.7 is your homework assignment, as you know, and we're going to do it together. So as I suggested in the directions there, if you have a printer and we're able to print off this worksheet, it might be a little bit easier because we're just going to do it together. Okay, but if you do not have a printer, you're unable to print, that's okay. Just make sure you copy it down. Each problem, title it Worksheet 5.7 at the top, put your name on it, and then do it together with us. Okay, so it's going to be very similar to the other video that you just watched. We do the same type of stuff. Okay, so and when you're done with this, take a picture, send it in, and there's your freebie. Okay, all right, so here we go. We're going to try and solve this equation and then tell us how many of each kind of solutions there are. Okay, so when I look at this, I see three terms. I don't see anything special about it. I don't see any greatest common factors. I don't think I see any perfect squares or perfect cubes, but I think the main way to do these, if you can, is to try and solve them by factoring. So I'm going to try to do my two parentheses here. Okay, if you remember, we look at the first term and the only choices are x and x. Then I go to the last term. Okay, and your factor sheets are probably going to be a little bit helpful here. But there's the factors of 10, 1 and 10 and 5 and 2. And we need to put them in there so we get -3. Okay, well, I think if I put a 5 there and a 2 there, and if I do my little FOIL test here, that gives me 5x, that gives me 2x. Can I get -3 using those numbers? And I think I can if the 5 is negative and the 2 is positive. Okay, -5 plus 2 is -3. So here's where the 5 came from, it's negative. There's where the 2 came from, and it's going to be positive. Okay? Now if you remember, I want to find the solutions now, I want to find the zeros. There's one of two ways you can do it. You could set these two things equal to 0, because that's kind of the fail-safe way. You can always do it that way and then solve it. X would equal -2, and if I add 5, x would equal +5. Okay, but hopefully as we're getting better at this factoring business, you can maybe skip that step. Okay, and if you didn't, that's fine. Okay, but some of you might be able to go right from here. If you see x plus 2, you know the solution is -2. X minus 5, the solution is -5. So you don't necessarily have to show this amount of work, but you should show how it gets factored and then the two solutions. Okay? And obviously I just said there's two solutions, but what kind of solutions? Are they real or are they imaginary? Well, we don't have any i's, so what we have here is we have two real solutions. Okay? And there's problem number 1. Okay? Just a kind of a straight up factoring problem from a while ago. Okay? Let's try number 2 here. I'm going to scooch this up. Here's number 2. Okay? And once again, here I see 3 terms on this one. Okay, so I'm going to eventually try and factor. But something else I see in this one is I think they have a greatest common factor. And if you look closely, I think all of those terms have an x in it. So I always look for the greatest common factor first. And if I take an x out in front, okay, this is supposed to be an x cubed, by the way. It's a little bit hard to see. Okay, but it's going to be x squared plus 12x plus 32. Okay, that's an x cubed out in front out there. That's smudged a little bit. Okay, well, I know I want to find the solutions. Well, as I said before, anytime I have an x out in front, there's one of my solutions. I have a 0. And by the way, just to reiterate here again, that the corollary to that fundamental theorem says if I have an x to the 3rd power, I should get 3 solutions. Okay, and again, we know that some may repeat, but I should get 3 of them. Well, there's one of them, x equals 0. Okay, then I can go to this part. Okay, there's 3 terms, just like the last problem, and I'm going to try factoring. Okay, I think factoring is the way to go if you can. The only choices for x squared are x and x. And how about the factors of 32? Okay, if you look at the factors of 32 on your factor sheet, okay, there's several of them, but there's one pair that works that adds together, subtracts to get 12. Okay, and I think it's 8 and 4. And if I did a +8 and a +4, when I check here, +4x, +8x, I get 12x. So it's going to work for us. Okay? And if I want to find my solutions, this time I'm going to use my little shortcut. If it says x +8, I'm going to get the opposite. -8 is a solution, or a 0. And same thing here, if it says x plus 4, I'm going to get negative 4 for a solution. And it looks like I did get my 3 zeros, my 3 roots, 1, 2, 3. Okay, I don't see any i's. So how many and what kind? I have 3 real solutions in this case. Okay? So those are, again, pretty much straight up common factoring problems. The special thing about this one is we had to take out the x first, look for its greatest common factor. And again, that's something I always do. Okay, let's move on to number 3. Whoops. Here's number 3. Okay. Many of these problems, many parts of these problems are going to be very similar to ones we've done in our notes, done in our other videos, and even in some of our old homework assignments. Okay, here's this guy. I see an x to the 4th. Okay, and more specifically, I look at the number 16 and 81. I'm thinking to myself, hey, they're special kind of numbers. I think they're both perfect squares. Okay, and I see the subtraction sign between these two things. So I have a difference of perfect squares. Okay, and that's going to be that a plus b and a minus b thing. I think I can factor these. They don't have a greatest common factor. But 16 is a perfect square. I could do 4 and 4. X to the 4th is a perfect square. It's x squared and x squared. And we know 81 is also a perfect square. It could be 9 and 9. 1 is plus, 1 is minus. Okay? Now, once I factored it into that, let's look at what I have left over. Can I factor any of those any further? Okay, maybe you recognize this first one as being a difference of perfect squares again. 4 is a perfect square. I could do 2x and 2x. 9 is a perfect square with 3 and 3. 1 is plus and 1 is minus. Okay? That one factored out one more time into those two pieces. And again, if I use my shortcut here, let's see if you guys can remember this. I have 2 solutions staring at us there. Remember, it's the opposite of this number, which is going to be negative 3. But now I have a number in front of the x, so I have to divide by it. It's going to be negative 3 halves. And this one would be positive 3 halves. Okay? Now, when in doubt, if you didn't get that, you could set them equal to 0, and you could solve it. Okay? When I look at this one, though, they're perfect squares, but it has addition in between them. We can't do the factoring when there's adding in between them. So how do you solve that? What we do is this is where we do set it equal to 0 and solve. So I'm going to say 4x squared plus 9 equals 0. Okay, I'm going to subtract 9, which is negative 9. I'm going to divide by 4. And I get x squared equals negative 9 fourths. Okay, that's a fraction, that's okay. But we know next that we have to get rid of the x squared. So I'm going to do the square root of both sides. Okay, well, how do I square root a fraction? Well, when we square root a fraction, let's just separate it into its numerator and denominator. The square root of 9, negative 9 over the square root of 4. The square root of 9, and I get plus and minus, by the way, I forgot that, my plus and minus. Okay, when I do that, I get plus or minus 3 with an I, and the square root of 4 is 2. Okay, so there are my answers right there. Okay, started out with the 4th power. I should get 4 solutions. Okay, and we get 1, 2, 3, 4. And what I have for solutions is these two are 2 real solutions. And these 2 guys over here with the I's are 2 imaginary solutions. So we do get the 4. Okay, but this is kind of another common thing here with these. We break apart 4th powers into square and square. Oftentimes one of them you can keep factoring one more time. Okay, but if not, set it equal to 0 and solve it. And remember, whenever we do the square root, I almost forgot this, we always get a plus and a minus in our answer. Okay? All right, very good. 3 down. Let's take a look at number 4. Okay? Number 4 here, is a perfect cube. Okay, we spent several days factoring perfect cubes and working with perfect cubes. Okay? And hopefully we're starting to get a little bit better at this. Okay? So, do you remember how we factored the perfect cube? So let's give it a whirl. If you remember, it has a little piece, and then it has a big part to it. What goes in the little part here is the cube root of each of those numbers. Well, the cube root of x cubed is x. The cube root of 8 is 2, and I keep the same sign. So that's how the first part factors. The second part then comes from the first part. The number that goes in the first spot is the first number squared. Well, x squared is x squared. Then I always change the sign, so minus becomes plus, and then I multiply the two together. 2 times x is 2x, and then I square the last number. Negative 2 squared, this is always going to be a plus sign. It's positive 4. Okay, and I forgot to do this again here, but I'm going to go back and ask myself, x to the third power, we should get 3 solutions. Okay, so I factor the first part of the perfect cube. This first one gives me 1 solution. And again, x minus 2, the solution is positive 2. It's just the opposite of what's in that parenthesis. Okay, and then if you remember from earlier, from the previous video again, the second part, the big part of the perfect cube is not factorable. Okay, the way we have to solve this part is you have to use the quadratic formula. Okay, we need to show a little bit of work for this as well. Okay, and so when I do the quadratic formula, remember I have to identify what A is, B is, and C is. A is 1, B is 2, and C is 4. Now you don't necessarily have to write that down. I realize a lot of you guys can do that in your head. Okay, but here's the quadratic formula. X equals the opposite of B, so negative 2, plus or minus the square root of B squared. 2 squared is 4. B squared minus 4 times A times C, all over 2A, and 2 times 1 is 2. Okay, and our goal here, what we want to do next, is we want to simplify this stuff under the radical. Okay, and if you simplify that stuff under the radical, 4 minus 4 times 1 times 4, I think you get negative 12. Okay, now let's look at that number negative 12. Is negative 12 a nice number? No, it's not a perfect square. It's negative, I see that, so I know I'm going to have an I in my answer. But we have to simplify the square root of 12, and this again is where your factor sheet comes into play. Okay, we're looking for factors of 12 where one of them is a perfect square. Well, we're going to use 4 and 3. The square root of 4 turns into a 2. Okay, so I'm going to try and squeak it in over here. So I'm going to have negative 2 plus or minus 2i because of the negative, square roots of 3, all over 2. And again, if I look closely, we've seen this a couple different times. Is there something that can go into all 3 of those big numbers? Yeah, I can divide them all by 2. And they turn into 1s. So ultimately what I get here is negative 1 plus or minus 1i, or I, square roots of 3, and it's all over 1. You could put it over 1 if you wanted to, but otherwise there it is right there. Okay? We were looking for 3 solutions. We got 3 solutions. We have 1 real solution right here. And then over here we have 2 imaginary solutions. So we got our 3. Okay? But with the perfect cube part, always remember on the second part, you're going to have to use the quadratic formula. And you're going to have to show me a little bit of work. Okay? Not photomath's work, but our work. Okay? All right, let's go to number 5. Okay? The last one on the front here, way down at the bottom. Okay? Let's see if I can get that on there. Okay? Hopefully these are getting a little bit easier and we're getting a little better at this. Okay, but it certainly helps if you practice it a little bit. Okay, how about this one? Okay, now I see 4 is a perfect square, 1's a perfect square, so I'm thinking, well, maybe I can do the perfect square thing. But if I look carefully, the operation that's in between them is a plus sign, and we can't do it. So now what? Well, let's just try and solve it by using algebra. What if I subtract 1? And then I'm going to divide by 4. So I get x squared equals negative 1/4. Okay, well again, we don't want x squared, we just want regular plain old x, so I have to get rid of the square, and I'm going to square root both sides. Okay, and when I do that, I always get plus or minus, and if I separate my fraction over here, I get the square root of negative 1 over the square root of 4. Well, the square root of negative 1 is 1I, or just I, and the square root of 4 is 2. Okay, so I get plus or minus I over 2. And if I look closely here, it's a second power. I should get 2 solutions, and I did. In fact, I got 2. In this case, it's just 2 imaginary solutions. Okay? All right, well, that wasn't so bad. Okay, very nice, good job. And by the way, as you're probably figuring this out, if I go too fast, certainly feel free to push pause and rewind if you need to go back and revisit something. Okay, let's go take a look at the back. A couple problems left on the back side of this. Okay. Here's number 16. Okay, we're going to solve this one. And the first thing that strikes me at this one is that there's only 2 terms. Okay? And when there's only 2 terms and I see they're separated by subtraction, so I think to myself, well, hey, it's going to be one of those perfect squares. Okay, kind of the a plus b and the a minus b one. Well, I think they are perfect squares. If I did the square root of 16, we know the square root of 16 is 4, and it's going to be a 4x squared and a 4x squared. And the square root of 625, if you did that on your calculator, it's going to tell you 25. Okay, and because it's subtraction, 1 is plus and 1 is minus. Okay, and then let's look at those 2 things that we have factored here. I can't do anything with the plus one. We'll come back to that, but how about this guy? This guy I can continue to factor one more time. They're perfect squares again. I could do a 2x and a 2x. The square root of 25 is 5 and 5, and 1 is plus and 1 is minus again. Okay, and I kind of have I have 2 solutions staring at me here. Okay, if you can't see it, you can set each one of these equal to 0 and then solve it, but in your head, if you did that, you're going to subtract 5, you're going to get negative 5, but then you have to divide by 2. So negative 5 halves, this would be positive 5 halves. So right now I got 2 solutions. This guy up here tells me I should be getting 4. Okay, let's see if I can get the other 2. Okay, well this is not factorable, so I have to set it equal to 0 and solve. Okay, I'm going to kind of do the same thing. I'm going to subtract 25, and I'm going to divide by 4. So x squared is negative 25 fourths. Okay, now that doesn't divide evenly. It's not a nice fraction. It can't be reduced. But we're going to try to get rid of the x squared next. And when I square root the fraction, the square root of negative 25 is 5i over the square root of 4 is 2. And again, maybe I should have did this. 25 over 4 is 5 over 2, but there's an I in it because it's negative. So I have 1, 2, 3, 4 solutions. And how many of each kind? Well, these 2 guys up here, these are the 2 real solutions. And these 2 are 2 imaginary solutions. Okay? Yeah. All right, very nice. Good job. Okay, let's keep rolling here. How about number 7? We're getting there. Okay, this one's back to having 3 terms on it. Okay, oops, my lights just went off here. Hang on a second. Okay, and when we have 3 terms, it's usually just the regular factoring. Once again, when it's 3 terms, it's just a regular factoring. I don't see a greatest common factor. Okay, so I'm just going to try and factor it. Let's try this. Okay, let's try, oh boy, maybe my only choices are a 2x and a 1x. And these are my choices to be for 14. 1 and 14, 2 and 7. I need to get 5. Is that going to work for me? 1 and 14 is not going to work. What if I tried 2 and 7? There's 4x and 7x. that doesn't get me negative 5x. Okay? If I flip-flop my 2 and the 7, oops, that gives me 14, 14x and 2x. That doesn't give me negative 5 either. Okay? And like I said, the 1 and the 14 aren't going to work, so now what? What do we do if it's not factorable? Okay, factoring is great when it works. But what do we do when it doesn't work? Okay? That's when we have to use the quadratic formula. Okay? So, again, I'm going to let A be 2, B is negative 5, and C is 14. And unfortunately, the quadratic formula is a lot of work, a little bit more work than the other stuff, but hopefully by now we're getting good at it. Okay, so let's try this. X equals the opposite of B, positive 5, plus or minus the square root of B squared, which is going to be 25, minus 4 times A times C, all over 2A, which is 4. Okay, and let's try to get something under the radical there. What number do I get if I do, grab my calculator, 25 minus 4 times 2 times 14? I get negative 87. Okay. Negative 87. Okay, well that's not the nicest looking number in the world. So now what? Okay, it's not a perfect square. If you go to your factor sheet and you look at 87, it doesn't have any factors that are perfect squares either. There aren't any black ones underneath there. Okay? In fact, 87 might even be a prime number. It doesn't have any factors. So now what? Do we just leave it? Really close. The only thing I can do with this is the fact that it's negative. And because it's negative, what does that mean? It means it's going to have an I out in front. So I can simplify this one tiny step more. It's going to be 5 plus or minus, and I can put the I out in front, 87 all over 4. And there we got it. Okay, but we always want to try and simplify that radical if we can. If we can't, then we just leave it. Okay, there's number 7. There's a quadratic formula problem with an I in it. Oh, by the way, how many answers did I get? Or should I get? This was an x squared. So we should get 2. We did get 2 solutions. And we got 2 imaginary solutions. Yep. Okay. And once again, I'm just going to emphasize, there's a bit of work to show on these, so make sure you're showing your work as you go. Okay. Okay. All right. One last one of these. Okay. And I think we've seen this problem a couple different times. Okay, but here it is. Here it is again. 8x cubed minus 27. Okay, it's one of those perfect cube ones, isn't it? Okay? Because 8's a perfect cube, 27 is a perfect cube. So I think we can break it down and factor it with our perfect cubes. Okay, if I did my 2 parentheses here, I get a little part and a big part. Again, the cube root of each one of these is what goes in the first part. The cube root of 8 is 2 with an x, and the cube root of 27 is 3. Okay, to get the second part, remember, I square the first number, which is 4x squared. Change the sign. Multiply the 2 to get 6x. And then I add the square of the last number. And this problem kind of looks familiar. Maybe I did it in the other video. Okay? But here's one answer. And again, I could either set it equal to 0, or if you're getting good at this, you can use a shortcut. It's the opposite of this, positive 3 over 2, 3 halves. Okay, there's one solution. We're hoping for 3. Okay, and if with perfect cubes again, this is not factorable, so we have to use the quadratic formula. Okay, and I'm just going to write it down again. A is 4, B is 6, and C is 9. You don't have to necessarily write those down. Let's give it a shot. Here we go. The opposite of B, negative 6, plus or minus the square root of B squared, minus 4 times 4 times 9, all over 2a, which is 8. Okay, and if I simplify that stuff under the radical, okay, 36 minus 4 times 4 times 9, we get negative 108. Yeah, we've seen this problem before. 108 is not a perfect square. If you look at it on your factor sheet, and if you actually look at it, you're going to see 36 times 3. And the square root of 36 is 6. Okay, I'm going to run out of room real quick, but I'm going to go right up here. Okay, I'm going to get negative 6 plus or minus 6, and it's going to have an I because it was negative 6, or negative 108 rather. Square root's a 3, all over 8. Okay. And last but not least, I can divide a 2 into all of those. So I get a 3, and a 4. And my grand finale answer, if I put it all together, is negative 3 plus or minus 3i square roots of 3 all over 4. Okay, that's where I end up there. This has 2 imaginary solutions because of the I, and this is 1 real solution. Okay, 1 real, 2 imaginaries. Here's number 8. Okay. All right. Okay, the last 2 problems on our worksheet here kind of have us change gears a little bit. They want us to find the solutions. Okay, we'll take a look at number 9 first. We'll do this one over here on the left. Okay, this is kind of like the very last ones I did on the video just a little bit ago, the first video. Okay, we're trying to find the polynomial, we're trying to find the equation, the expression that gives us these solutions. And it's kind of just like doing the factoring stuff in reverse. If you remember x equals 5, that comes from x minus 5. X equals negative 2 comes from x plus 2. And x equals negative 1 comes from x plus 1. Okay, and then all we really have to do lastly here is we just have to multiply all that stuff together. Okay, well we can only multiply 2 things at a time. So I'm going to multiply the first 2 together. And I'm going to FOIL it. Okay, I'm going to get x squared plus 2x minus 5x minus 10. And I get x squared minus 3x minus 10. And I did that kind of fast, but that's when I get when I multiply the first 2 terms together. I now have to multiply that by the third term. I have to multiply that by x plus 1. And if I FOIL that, I'm going to get x cubed plus x squared. Then I'm going to take the 3 through. I'm going to get negative 3x squared minus 3x. And then I'm going to take the 10 through, minus 10x minus 10. Okay, and if I combine my like terms, then it says it wants it in standard form, so we know it has to go from the biggest exponent down to the smallest exponent. Well, the biggest one I see is x to the third. I see a couple x squareds. 1 minus 3 is negative 2x squared. These 2 together combine to give me negative 13x, and then minus 10 is way out there at the end. Okay? Yeah, so when you go backwards here, it's just a couple FOIL problems. A little bit of multiplication. Okay? All right, and last but not least, coming up is number 10. Okay, let's give that a whirl here in a second. Okay, number 10 here has one of those I's in it, which from the first video said there's something special about our answers when we get to that one. Just do that like that. Okay, but we're going to do exactly the same thing. X equals negative 3, that comes from x plus 3. Where's my eraser? Here we go. It comes from x plus 3. Sorry. x equals 1 comes from x minus 1. And if you remember from the first video, when it has an I in it, it actually comes from two different answers. One of them comes from x plus 3i, and the other one comes from x minus 3i. Okay, so it actually has four solutions, so to speak. Okay, we're going to multiply the first two together. I'm going to FOIL these. I get x squared, and I'm going to do this a little bit faster here. I'm going to get minus 1x plus 3x. Negative 1 plus 3 is positive 2x minus 3. I think there's some of you guys that are able to do that a little bit faster, which is fine. Okay, so there's 1. I'm going to just kind of leave it separate here. When I FOIL this over here, I get x squared. And if you remember, these are conjugates, and the middle terms are going to cancel out. I get a minus 3xi and a plus 3xi. They cancel out. Now be really, really careful here. 3 times negative 3, it looks like negative 9. But whenever you multiply two i's together, I times I makes it negative 1, or it changes the sign. So there's what that one multiplies to, there's what that one multiplies to, and now we got to multiply the two things, those two expressions together. Okay? I'm going to start by taking the x squared and distribute it into each of these. If I do that, I'm going to get x to the 4th plus 9x squared. Then I'm going to take the 2x and multiply it through. I get 2x cubed plus 18x. Then I'm going to take the 3 through, minus 3x squared minus 27. Okay? So 18x minus 3x, yep, I think we're good. In standard form, it wants us to write them in order from biggest to smallest. The biggest one I see is x to the 4th. That one's gone. Okay. I see an x cubed right here. That's the only one, so plus 2x cubed. 9 minus 3 is 6x squared. Plus 18x minus 27. And there we have it. Okay. So once again, we did this whole assignment together, which is great. I'm hoping you were able to follow along, and as you did the work, it's kind of processing and registering and kind of clicking a little bit better. All right, good job. Make sure you take a picture of this and resubmit it, or not resubmit, but take a picture of it, send it back to me, and you're all good to go. All right, thanks for tuning in. Good job.